Hi, Kevin. You want to say hi? Anybody else wants to say hi before I start? It's just 5 minute intro, and then we're going to do Q&A and presentation with Liz. You're in for a treat, folks. Okay? Then let me go. So let's make this bigger. So welcome to ServerlessTO user group. Unfortunately, we're now online. Fortunately, we still have our knowledge sponsor with us. Manu has been with us for over 2 years, and like preparing for this meetup, I was looking for the SRE titles they have, and I was really surprised to find not only the book on SRE but book on honeycomb. So for this meetup, we're going to be giving not one but 2 copies of the ebook Software Telemetry, and you're in for a treat. So make sure you go to this Google form. John, can you paste the link to the Google form again? Because people who join late, they will not see the link. So while I'm talking, you can register. We are not taking email addresses, not spamming you. This is just to educate us how to be better. And thank you, sponsor. About the upcoming Serverless Toronto user group meetups, if you go to this link, you will see specific dates. Amazon event is coming, and I'm going to have my friend James Beswick from Amazon do the recap from the service point of view, and it's going to be just before the Christmas holidays, so you're going to be able to kind of get lots of homeworks, what to research through the holidays. In early January, we're going to have Reid Tseng. He's one of the authors of the Google Spring Cloud GCP framework and developer advocate for Google. He's going to be talking about doing cloud native Java using just those Spring Cloud GCP extensions. This is important talk because way too many companies believe that they have to have a platform on top of the platform, and over the last 10 years, cloud itself has become a platform. As of recently, Azure has announced fully managed Spring Framework services, so you no longer need frameworks like OpenShift or Pivotal Cloud Foundry, or even Kubernetes to run cloud native Java apps. So even if you're not in Google Cloud, I really encourage you to come to this talk, because if you're Java developers, you're more cloud native than you know. Then in February, it's 3 years since we created Serverless user group, and it's going to be a bunch of short lightning talks for the community members to talk where we were, where we are going. And then after that, we have nothing planned, so we need you to help us with your talks. They don't have to be professional, just your experience, so we will improve our knowledge. And then I will share this slide deck. You will be able to click on each of the links to register and to research why Serverless Toronto user group. I will not go deeper into the slide about us, and that Serverless is it's not just technology but the mindset. You can catch up with that in our previous introductions. However, lots of you are wondering why DevOps topic on the Serverless meetup. So looking back, when we just started, I was invited to Montreal AWS user group to present about Serverless framework, and I used this slide about SDLC principle, tossing the code over the fence. And really, at the time, the idea of Dev and Ops was like a line connecting development ops. But in my life, in the practice, I noticed the DevOps team became like third silo. So you had like 3 roles to hop, not the connection between the two. So this love for serverless was really my utopia towards NeoOps idea. And then back in 2018 also, sometime almost 2 years, more than 2 years ago, we had a talk for startups where we were addressing also this conflict within big corporations where Dev and Ops, and now the third, or DevOps, were cannibalizing one another and really tying their hands behind the back. And we were encouraging startups to compete and not to be afraid of big companies because they were slow. So fast forward 2 years later, I think that this obsession with startups and serverless was escape from the corporate reality I was living in before discovering serverless. Now I'm working for the major big company in Canada, pharmacy, and they are using Google Cloud. So as you keep researching and learning about the Google Cloud, you cannot not to run into the topic of SRE, site reliability engineering. And site reliability engineering is Google's way of implementing DevOps. So there was DevOps philosophy into the middle way of practicing it. And I got so excited, like it was really the excitement for reliability, this focus on end user experience. And then like the shift was from dev and ops to the users. So you will see that even service level indicators are defining like where the end users are not happy. And I started diving deeper into the topic. Everywhere I go, there is Liz videos. So I pasted here one short playlist. I really love that one that you did, Liz, about SRE principles. And then also because I was attending lots of serverless events, every time Charity was talking at the conferences, you were outside at the Honeycomb booth. But at the time, I wasn't ready for like observability was as interesting to me as logging. So how they say, like the student, when the student is ready, the teacher will appear, and luckily you and Charity are now here to help us resolve these DevOps, Dev versus Ops conflict. So that's why we have this talk. It's just my discovery that we don't need to run away from the things, but we can face them, and then there is a better way to address them. And this is a picture.
Hey, Daniel.
Yep.
Sorry, can you just check the waiting room? I think we've got some people trying to get in. I think only you can do that.
But it's auto. I'll do it. It's auto. On. Okay. Huh. This is interesting. So that's basically my part. I don't know, like all the slide decks, all the slides will. So when you get them, you'll be able to click through and find all these videos that impressed me. This one particular was Liz, you were at the Detangling conference, and that was one of the best introductions about SROs. So you will folks be able not just to go through the video, but also see the slides. So that's my introductory talk. Liz, is Charity here to give her part, or are we going to kind of have folks talk to you?
Let me ping Charity on Slack and see where she's at.
Yep, it's all good. Like we have experts here. So, but I like to start top down because Charity talks about philosophy, emotions, like focus on the user, and then listen, practical and show you how to do that. It's just this mission that their company has. It's a new company, like it's.
Just get the audio set up for a minute.
Yep, we can see you, Charity. We cannot hear you yet because you are on mute. So go to the bottom of your window. There should be a perfect.
This is always my tech support.
Hi, good to see you.
Hi there. Sorry I was
How
late.
are you holding up?
Oh, you know. How are her name is holding up? Can't complain too much. It's all right. Sorry I'm late. I had to do an interview.
No, we're not late. We were just chatting and we had problems with Google Meet because they switched free version to something else paid, and I cannot record.
Computers. Wonderful.
Hopefully we'll be able to see the good pitch I gave for the company.
Wonderful.
I'm kidding. So folks, we're going to have two presentations. First, you're going to see Big Y, and then Liz is going to do her part, and then you'll be able to ask her questions. Then, questions.
Sorry, am I going first or is this going first?
Yeah, you are. Like,
You're going first, Charity.
And then practice.
Okay. Okay. All right. 1 second.
At the bottom, present.
I'm getting. Yeah, I'm just getting a little beach ball here.
How was the interview?
Oh, it was great. He was delightful.
This is good to hear. So,
Just pulling it up here.
we're looking for people. There are lots of DevOps folks here that may contact you. Am I right?
We are actually hiring one SRE.
Cool.
All right. I'm going to project.
At the bottom.
Down at the bottom. Oh, my computer is so slow. There it goes. Present. Well, I probably want to present my entire screen, huh?
Yeah.
Present entire screen. Cool. Okay, and now I'm hitting play. I should probably switch my work laptops and home laptops. All right, do you see my slides?
Not yet.
Yay, we did.
It looks good.
Yay. Well, I'm going to be talking about the socio-technical path to high-performing teams. How long should I take?
We have whole
45 minutes or so. I think we allocated 45 minutes to me and 45 minutes to you, Charlie. I might run a little shorter than that or longer, depending upon how many questions you will have.
Mhm.
Sounds great. All right. Well, I'm going to assume that everybody knows who I am. If not, I'm Charity, ops engineer, author of Database Reliability Engineering. Liz and I are actually collaborating on an observability book for O'Reilly, which should be out sometime next year, assuming we finish it. We don't know what animal we're going to be yet, so TBD. What I'm going to be talking about today is teams. Teams are, I think of them as RAID for humans. Like, they make sure that, teams that maintain things that are too big for any one person to deliver, they're also an abstraction interface for the rest of the company. Right? If someone goes on vacation, people all over the company shouldn't have to worry if this means that your team can meet your goals or not, because the team takes care of things like redundancy and load balancing, scaffolding for the growth and development of each individual. And I feel like, I often talk to people who are thinking about changing jobs, and when I ask them what they want, I hear a lot of things. Like, they want to work on specific technologies, they want good work-life balance, they want company culture, opportunities, etc. And I rarely hear anyone say the one thing that I think is by far the most important thing to look for, and that's that you should want to join a high-performing team. The teams that you join will define your career more than where you go to school, more than your industry, even more, I would argue, than your own personal skill level or ability. I feel like I won the lottery early in my career. I worked at Linden Lab for 5 years straight out of college, which set a very high bar for me. Cutting edge technology, problems, brilliant, passionate people, fierce creativity, and a very generous, open culture. And from them, I learned a whole universe of best practices, things that honestly have taken thousands of engineers, tens of years to arrive at. And it was a great way to launch my career. It set the bar very, very high for me for the rest of my career, and I'm very grateful. After that, I had a couple of not so great years. I'm saying this because we're in a small group here and it feels relatively safe, but like, I had a couple jobs after that where I stayed at for a year and a day each. Neither of them were the worst, but they weren't really for me. Like, the first one was down in Silicon Valley. I was like, I'm going to do cutting edge stuff with mobile. I took a Caltrain to Palo Alto every day for a year. I didn't really believe in the product. I felt better about the world when it was down, right? It was gamifying people's.
I lost sound.
One by one. Assignments. Again, I stayed there for a year and a day. I felt like I owed them that year. In retrospect, I did not. I should have left. But after those 2 years, like, I was the closest I've ever been to burning out. And it wasn't because I had been overworked. In fact, these were the cushiest jobs of my career. Like, I worked 2 hours a day at the second job, and maybe 4 or 5 hours a day at the first one. But I was burned out because I didn't care. And I was burned out because it just wasn't a good fit. Then I found parse and it clicked. Anyway, these jobs had nothing in common with each other except the way they made me feel. Which was the column on the right. It's the way that they made me feel, right? And this is like what I've been learning the course of my career. And it's experientially before I really understood why these teams made me feel bad or good. High-performing teams are part of what make life worth living, right? Autonomy, mastery, and purpose. Your work can and should be a creative force that you hunger for, something that's worthy of you investing your life into. If you haven't read Dan Pink's research, it's good. I mean, it's a lot of nodding, going, "Oh yes, duh, obviously," but sometimes we need that, right? High-performing teams deliver the ingredients that make work not a chore, but a critical. Because this is not just about finding teams where people make you feel good. It's also about high-performing, right? All of these people that I worked with, they were all doing their best, right? But you need both for people to be doing their best and really putting themselves into it and being kind and being equal and all these things. But you also need to be high performing. And what I want to talk about today is how to build high performing teams for sociotechnical systems. Sociotechnical systems are comprised of socio, right? Us, our teams, people, the systems, production systems that we work upon, and the technical tools that people use to work upon those systems. This is definitely my favorite new word. I'm using it all over. And part of the reason I love it is because you already intuitively know what it means when you hear it, right? And you know why it matters. One really big implication of sociotechnical systems is that if you want to change the way people behave, if you want to change who people are, you can sometimes do this just by changing the tools that they use. If you want to read more about this, I recommend, this is the famous graph by Dr. Richard Cook. Richard Cook and John Alspot have done all this amazing research in sociotechnical systems. I'm not really going to be going into that, but I thought it was important to drop this here so that you see it. The language that they use is values, practices, and tools, and we're going to be using the terms team, tools, and production. The first and only one of it in the universe. Each of our sociotechnical systems are sui generis. They are unique. There will never be another one exactly like it, right? They are full of emergent behaviors that are more than the components that comprise them. And you cannot, if you want to improve the sociotechnical system, you cannot only work on one part of it, right? You can't just focus on the people. You can't just focus on the tools. You can't just focus on production, even though that's where you tend to see most of your results. There are some best practices that I'm just going to list here really quickly before we move on. Hiring growth-oriented people. These systems are so incredibly complex. They're changing all the time. That's not really going to work out for you very well. If you want to hire people who are comfortable with discomfort, you need to build emotional safety, because it has to be safe to fail, because you're going to be failing a lot, like a lot. It needs to be safe to fail. You need to invest in good tooling. You need to be constantly paying down that technical debt and maintaining it as a budget. You need to practice observability-driven development. Instrument, observe, iterate, and repeat. And so much of this labor consists of feedback loops, constructing them, tweaking them, improving them. Feedback loops are incredibly powerful. And this is not just a job for managers. It's not just a job for senior people. This is a job for every single one of us. Since our tools have not yet become self-aware, our production systems, it is the job of the people in the sociotechnical systems to improve them, to be conscious and aware of them. You can't fix what you can't measure. How well does your team perform? I'm going to assume most of you are familiar with the DevOps metrics, but let's run through them again really quickly. And huge thanks goes out to Nicole, Jez, and Jean, because until they did their work at Accelerate, which you should all read the book, or at the very least read the State of the DevOps reports, we were all kind of flying blind, and we all had our passionately held beliefs about what should be done. But Nicole and Jez were the first to really bring some science to the party. And they came up with these first 4 metrics. How frequently do you deploy? How long does it take for your code to go live? How many of your deploys fail? How long does it take to recover from an outage? And I would add this 5th. How often are you alerted, especially after hours? These metrics, every single one of you should know. This is how you know how high performing your team is. And if you don't know the answer to these questions, start there. You should be watching these. You should know these. You should know where you're trending. You should know what you're weak at. You should know what you're strong at, because in so many ways, this is, shipping code is the beating heart of your production systems. These things tell you how well you are doing that. This should come up in leadership performance reviews. This should come up in senior engineers performance reviews. This should show up on your job ladder. I also want to drop one more bit of science in here, which is this great Stripe developer report that they pulled tens of thousands of developers, and they're like, how much of your time is wasted? So like, this is like this is the optimist's take on it, right? At a minimum, we spend 42% of our time on the stuff that doesn't move the business forward, not learning anything new, not creating anything. It's just doing the work that you have to do in order to get to the work that you need to do. Orienting yourself in time and space, trying to reproduce errors from bugs, trying to figure out what to do, doing the wrong thing, having to undo it, having to redo something. 42%. Jesus Christ. This is insane. This is insane. We think this is normal. This is not normal. It is not normal, and it is not inevitable. And this is where we start to dip our toe into observability, because, I use the metaphor of glasses a lot. You put your glasses on before you drive down the street, before you drive down the highway, for fuck's sake. If you can't see where you're going or what you're doing, this feedback loop is going to be long and lossy, and you're going to spend more time studying yourself, orienting yourself, than actually doing the work. With observability, you start to get a handle on yourself and what you're doing, and get used to driving with your glasses on. Back to the door report metrics. So there's a huge gap here between the median performing team and what they call elite performing teams. The low and medium performing teams are about 50% of all teams, and they deploy between once per month. Elite teams deploy multiple times a day, right? These bubbles are telling, and a little bit scary. If we look at the difference between 2018 and 2019, the bottom 50% are actually losing ground. Because in tech, if you're standing still, you're losing ground, because chaos, because entropy. But you also note that like the top, elite 7% of all teams were, as Dora calls them, elite teams. In 2019, that's grown to 20%, and they've gotten better. It crushes my soul that Google acquired them and we will never have a 2020 survey, because I suspect that even more teams are now elite, and that the bar has gotten even higher. We'll talk more about that in a second. For now, I just want to circle back and show you that it really pays to be a high-performing team. Like, really. Like, think of the sheer amount of human misery contained in that goal. 208 times more frequent code deployments, 106 times faster lead time from commit to deploy. Think of like all the times that you have figured out a problem, paged it into your brain, you know it inside and out, and then by the time it's deployed, you've forgotten it. And it breaks, or some subtle problem happens, and you learn about it 6 months later or a year later, and you have to go page it back into your into your brain, figure it out again. Like, oh my God, I almost feel like this is undercounting the amount of pain that's involved here. Who's going to be a better engineer in 2 years? The person on the left in the high-performing team, or the person on the right in a medium-performing team? 3,000 deploys per year versus 5 deploys per year. Every deploy is a chance to learn, right? Someone who's working on an elite team, shipping 12 times a day, is going to learn a lot more, a lot faster than someone who's shipping 3 to 10 times per year. And like, who do you think is going to be a better engineer? What's another time sink? Firefighting, right? Elite teams have 1/7 as many outages, and they resolve them 2,600 times faster. 2,600 times faster. This is not a typo. And what happens when an engineer from the elite yellow bubble joins a team in the medium blue bubble? I mean, if you listen to like all of the recruiting firms in Silicon Valley blowhards, you would think that, you know, it brings a team up to the elite level, and it's not true. Within 3 to 6 months of joining a team, your productivity tends to rise or fall to match that of the team that you joined. Because so much of your ability to execute depends not on your personal ability to write algorithms and data structures, but on the library support and tooling, the standardization of the tool chains, the architecture, the dependencies, the technical debt, the tooling for shipping code, the observability, the ability to find problems once it's been shipped. We're a very individualist culture, which is why that we tend to think of ourselves as like 10x engineers or whatever. But in fact, there are 10x teams, and they build 10x engineers. Elite teams build engineers, not the other way around. Great teams make great engineers. And furthermore, every engineering org has a dual mandate. It's not just about customers. As much as Amazon's like fanatical, I mean, this Rackspace fanatical support, that's great. But you have a dual mandate. It's the reality is that the engineering happiness and the sustainability of systems are closely entwined. Systems that are observable are easier to own and maintain, which means it is easier to be an engineer who owns said systems, which means you get to write more code, ship more stuff, do more experiments, move faster. Happier engineers means less turnover, less time and money spent ramping up new people. You can run more systems with fewer humans. Ultimately, observability is about operating your business successfully, and having the visibility in your systems that observability offers means the organization can better understand what your customer base wants, as well as the most efficient way to deliver it. If you try without observability, you'll make some headway. You're going to be stumbling around in the dark like a blind person. A lot of your success will be determined by luck, not science. The bottom 50% of all teams are largely trapped in a cycle they just can't get out of because they literally can't see what they're doing. They're stabbing around in the dark and running down the clock. This brings us to tools. I don't know exactly what each of your teams needs, but after seeing a lot of them over the past few years, I think I can guess. Every team is a snowflake, every workload is a snowflake, but we can genericize to some extent. But let's talk about observability for a little bit first. In control theory, observability is a term taken from mechanical engineering, and it means how much can you understand the inner workings of your software from absorbing its outputs. I like to think of it as your ability to understand what's happening without attaching a debugger to the process. If you translate this into software terms, it means, can you understand what's happening inside your systems just by asking questions from the outside without shipping new code, right? Anyone can understand what's going on inside your systems if you ship new code and handle that scenario. But if you ship new code to handle that scenario, that implies that you could have predicted in advance that you needed to understand it, which that's a known unknown, right? This is about unknown unknowns versus known unknowns. Monitoring is great at helping you do known unknowns. Observability is good at helping you understand unknown unknowns. To be clear, I'm using the technical definition of observability, the 3 pillars definition, Not the, there are a lot of vendors out there who've just been like, me too, and they're jumping on the observability train and claiming that they do it. I guess the market will decide whether or not they win, but in my book, they do not. Signs that you're using observability means that you're you can tell because your system is, the source of truth is these arbitrarily wide structured data blobs. You're allowed to visualize by time or trace. You propagate unique request IDs and span IDs throughout the stack. If you're not using observability, you're based on metrics like Prometheus, Datadog, Signal Effects, Wavefront. Unstructured logs, not observability. Anything that requires indexes or schemas, not observability. Now, I've written about this a lot, so I'm not going to go very deeply into this here. If you want to know more, there's a link at the bottom. Observability technical dependencies rely on things like high cardinality, high dimensionality, all this stuff, because these are all that we have found are required in order to enable you to ask any question of your systems and understand any internal state without having to predict it in advance. That's all. Maybe other ways exist. These are the ways that we found. The objection that we often hear is, we don't have time to invest in observability now. But like the acceleration of complexity in your production systems means that it's not a matter of if, it's when. And you kind of can't afford not to. And the sooner that you do it, the better off your teams will be. Now, Liz and I don't know if Liz is going to talk about this more later, but like we spent a bunch of time going into a maturity model. And you follow that link and read the white paper. You can kind of use it like a choose your own adventure, like which are we weakest at? Is this where I'm weakest? Is that where I'm weakest? Following the symptoms that we talk about. So that's kind of a way you can help triage and figure out what to invest in first. I think of observability kind of like a headlamp, right? You instrument as you go so you can see what's in your hands, and then you move on to another part of the system. You instrument first. And eventually over time, just by trying to understand and respond to systems, I'm willing to run the entire thing. But anyway. Observability is the key to making the leap from these known unknowns to unknowns and software lifecycle ownership. And the reason that we're going to say complexity, right? Our systems are now ephemeral and dynamic, far-flung, loosely coupled, partitioned and sharded and distributed and replicated, all in the name of resiliency and reliability. If we look at these graphs here, like this one on the right-hand side, that's the national electrical grid. And that, I would argue, is how we should be thinking about our complex systems. If a tree falls over in the middle of bumfuck Iowa, can you have predicted that it would happen in advance? No, and you probably shouldn't try. Instead, you should invest in the right kind of instrumentation to make it so that you could swiftly triage and diagnose and pinpoint and ship the fix. Observability is what connects your effort to your output, to cause to an effect, and helps you iterate and improve on what works. And here's where I feel like I should give an example, because a lot of people are like, okay, but actually, what does this mean? Which is a fair question. So let's take a question that I'm going to guess most, if not all of you, have tried to debug before. Photos are loading slowly, but only for some people. Why? And this is in the lamp stack era. There's a pretty predictable set of, you can build one of these lamp stacks. You can look at it, size it up, guess 80% of the ways it's ever going to fail. All right, things are going to run out of connections. The tier is going to exceed capacity. The application is going to throw a lot of errors. Right? You can monitor those things, and you should. Monitoring is an incredibly useful set of tools and best practices. Now let's look at this. Photos are loaded slowly for some people. I'm in a modern microservices environment, and all of these were taken from real outages that we had at Parse or Instagram. Okay, not exactly sure what I'm supposed to monitor for. I've got more. Latency reverts to the historical mean on Tuesdays. I know what you're thinking. It is not a cron job. I could do this all day.
Everyone has their war stories.
Everyone has their war story. Right. And what all these things have in common is that it happened once. And in the past, like, our pattern has always been like, you know, oh, something new happens. It's astonishing, it's startling, you know, it's hard to figure out. All hands on deck. We figure it out. And then we have a postmortem, and then we have, like, you know, we'll write, you know, a playbook, and we'll make some dashboards, and we'll, like, you know, create a graph that will show us immediately the next time we write a monitoring check for it, right? And but that's only a useful set of things to do if it's going to happen again. If it's a one-off, if it's something incredibly rare, then all of that energy was kind of wasted. And maybe what we should be investing in instead is the ability to swiftly diagnose these things in flight. You have an observable system when your team can quickly and reliably diagnose any new behavior with no prior knowledge, and confidently so, right? You know, at Parse, you know, the thing that led to us creating Honeycomb was really the fact that, like, you know, Parse was this, we were doing microservices before there were microservices. We had started having terrible platform problems, like co-tenancy issues, where you couldn't figure out which app had caused everything to get slow, but everything got slow and all went down. And the first glimmer of light that we had, like, I tried every tool out there. The first glimmer of light we had was when I got some data sets into Scuba, which with aggressively hostile users did one thing well, let you slice and dice in high cardinality dimensions in near real time. And suddenly the time it took us to, like, diagnose which app it was dropped from, like, open-ended days, God knows, to seconds, like not even minutes. Like every time, just like slice and dice. Oh, it's that one. Oh, it's that one. Oh, it's that backend. Oh, it's that query. Oh, it's that user. And that's transformative. Like when you gain confidence in your tooling to, like, swiftly identify any new behavior, then suddenly you can release your grip on the dashboards and the playbooks, and all of those things are really a relic of ages when it was very difficult to debug your systems, and genuinely new things happened rarely. I want to talk a little bit about observability-driven development, because observability-driven development is really the key towards shrinking the amount of time between when you cause a bug and when you find it. First of all, you should never accept a pull request unless you can answer the question, how will I know when this breaks? Because it's not if, it's when, right? How will your instrumentation show you when this code is broken? You should also watch your code go out. You should make it muscle memory. Honestly, if there's any one thing that teams could do to, you know, it's like, you know, the concept of cornerstone species, you know, or cornerstone habit, where you get this one thing right, so many virtuous things flow from it. That would be shrinking the amount of time between when you write the code and when it's live in production. It doesn't have to be live for everyone, right? You can use feature flags, you can whatever, but like if you can shrink that to a matter of a small number of minutes, and if you can make it so that it's more or less an atomic action, so that when you merge to main, it will be live automatically without anyone having to manually do anything. If you can get that one thing right, oh my God, so many things just magically get better. You know, you can make it muscle memory to watch your code go out. You can make it muscle memory to go and look at your changes once they're live. You can make it muscle memory to be instrumenting as you write your code with an eye towards future you. How is future you going to understand this code? And then you go and you fucking look at it. And is it working as intended? Can you tell with your instrumentation if it's doing what you meant for it to? And does anything else look weird? observability-driven development. That is how, at Honeycomb, our Dora metrics are like an order of magnitude better than these so-called elite teams. We've been writing code, for the last 2 years, we've been building Honeycomb with fewer than 10 people writing code full time. And the only way that we've been able to do that is that we have not been wasting over 40% of our developer cycles. They've been able to move swiftly and with confidence. And the way that you do that is by getting this feedback loop tuned and tight. On call is where shit gets real. When people ask me, where should I start? People will sometimes ask me, how can I get my developers to care about their code? And my answer is always, are they on call? On call has a way of making people care about things. But like there's a handshake here where, yes, I believe that everyone who's building, these 24/7 highly available systems should be on call for some definition of on call. But in exchange, managers have to make sure that it does not suck. It can't be terrible. It can't be something you have to plan your life around. It can't be something that you dread. It can be something that, you have to remember to cart your phone and your laptop around for a week. That's not terrible. But like it can't, my bar is basically no one can get woken up more than once or twice a year for their service. I believe it's reasonable to ask anyone to get woken up once or twice a year for their service. More than that, not okay. Even beyond that, though, like we need to be incentivizing and encouraging people to be up to their elbows in production every day. If you're shipping code every day, you should be looking at it every day. It should feel wrong to just like write some code, merge it, and walk out the door. That should feel very, very wrong to you. Investing in deploys, I think, is the number one. It's like the number one place where most people can have the most impact right now by investing in developer. Most people's CI/CD pipelines are fucking sloppy as hell. In fact, we have not even really, as an industry, begun to fulfill the promise of CD. Like we talk about CI/CD, but we really just need CI. CD is for real. CD is what will actually help close that loop and make it a tight, virtuous feedback loop. That doesn't, like I said, that doesn't mean that you need to make all your code go live instantly, but it does mean you need to get it out instantly. Progressive deployment is a new part, I think, for all the feature flags and this. I feel like there's a big shift right now in general. Just the center of gravity is moving throughout the industry from pre-production to production. And I'm not saying that staging has no value. Staging has some value. It probably doesn't have as much value as you're giving it in terms of developer cycles, right? I'm not saying don't have a staging system, but what I see over and over is people who invest tons of developer energy at building elaborate staging environments, a new staging environment for every developer, dog food development, all this stuff. And then when it's time to invest in tooling around production, well, we're out of developer cycles. Everyone has a fixed number of developer cycles. It's the scarcest resource in our worlds. All I'm saying is invest in production first and let staging take the leftovers, because that's what matters, right? Code that's not in prod is dead code. It may as well not exist. SLOs are important. They're an advanced maneuver, but they're one that every one of you should be working towards. And don't be scared by regulations. There's this weird meme or myth that's gotten around that if you're subject to financial regulation, then developers can't touch production. Absolutely fucking false. So let's talk through. I want to just try and illustrate for you real quick. I'm almost done. The insidious, how it is that 40-odd% of your time is wasted. Let's talk about the insidious loop and then the virtuous loop. The insidious loop is engineer merges a diff. You don't have it automatically connected to your deploy system, so time passes. Other people merge too. Eventually, someone sucks it up and triggers a deploy with a few days worth of merges. The deploy fails, or it goes live, there's a bug, whatever, it takes to the site, pages are on call, who is a different person than the person who is deploying the code, or the person who wrote the code. So they all start debugging asynchronously. Someone rolls back, starts git bisecting, trying to figure out which one of these changes, given that there are many changes, which one of these changes was the fatal change. This eats up the better part of her day. pulls in certainly anyone who's written a diff during that time. Everybody bitches about how much on-call sucks. When they finally recover, it's taken up several engineering days. A couple people are late for dinner. Everybody's pissed. Let's look at how this could look. Engineer merges a diff, which is an automatic CI/CD, deploys to prod. Deploy fails, automatically notifies the person who just merged and reverts to safety. Well, she knows exactly what she just did, so she quickly fixes it, adds some more tests and instrumentation to catch it better next time, commits a fix, all elapsed 10 engineering minutes. You can see how this multiplies over days, weeks, months, years, which is why it really, really, really pays to be on a high-performing team. In order to spend more of your time in productive activities, instrument, observe, and iterate. Most people's production systems are hairballs that the cat coughed up that nobody's ever understood. And every day there should be more code that nobody really understands to the hairball that nobody's ever understood. And then we wonder why our call sucks and our life is miserable. And this is not an inevitability. This does not have to be this way. Systems can be well understood. They can be highly visible. They can be, you can understand them. You can see what you're doing. But it does require investment. It's investment that pays off massively, but it does take some upfront work. Speed is safety, right? Like there's this fallacy where we want to slow down when we're anxious or when things get hard, which is like if you replace that metaphor in your brain with like a shark or a bicycle or ice skates or something, where the slower you get, the more you wobble, the more you die, right? Speed is safety. Getting your code into production within minutes is the best preventative medicine you can have. Let's talk briefly about build versus buy. I feel like this is a lesson that we're all kind of learning as an industry. Focus relentlessly on your core business differentiators, right? Engineering cycle, universe, and ops has a lot to teach you here, right? I'm not a great software engineer. If I'm writing some code, you know it's fucking necessary. Build reluctantly. All code is legacy code. Kill your darlings, right? My friend TVH likes to say that the best code in the world is no code at all. The second best code is code that someone else writes and maintains and you get to use. The third best code is literally anything else. Senior engineers, it is your job to amplify hidden costs and hidden rewards, right? Nobody is better positioned. Everybody is making the best decisions that they can based on the information that they have, and it's often your job to like amplify, be annoying, raise the costs that are going to make us suffer now, and don't just thank people once when they do something that improves the feedback loop, but point it out over and over. Point it out how much it's helping you. And 6 later, oh god, this thing. Can you imagine how miserable it would be if we hadn't refactored that thing, 6 months ago? It's important to draw people's visibility to the things that otherwise won't be seen, both good and bad. Practice good vendor engineering. I feel like vendor engineering is one of the next waves of, it needs a name, it needs to be a thing, because there's a place for observability teams, even if you're outsourcing your observability. Your observability team shouldn't be writing your own time series database, right? Lord knows the world doesn't need another one of those. It should be building shared libraries and modules, examples, use cases, driving consistent interfaces internally, building relationships, and just making sure that everyone internally is using your vendor in a similar way. It's really important that we promote people, not just for the hardest algorithms and like the most complicated data structures, but like for successfully offloading and outsourcing, for successfully making it so that your team can have more focus. That is engineering work. It is hard engineering labor. It is worthy of titles, bonuses, etc. Your system is a sociotechnical snowflake, unlike any other. High-performing teams both contribute to and are a consequence of a high-performing sociotechnical system. And I'm going to skip past this, I think, because I'm about out of time.
Take as long as you need, Charlie. I can only take like 20 or 30 minutes. That's fine.
Oh, okay. Well, then for fun, let's look at the sociotechnical implications of the dominant architecture models in the past couple of decades. There's monoliths, where like we had the database and the application. And we're very fragile yet predictable, right? Like we could predict most of the ways they were going to fail. We dealt with mostly known unknowns. Maybe a couple of times a year we truly stumped, right? And that meant that we would flip a switch to deploy, right? The changes were very binary, very big bang. And the social consequences of these systems were that production was to be feared, right? Failures were to be prevented. We debugged by like intuition, the scar tissue, library of past outages. Deploys were scary because most outages came from deploys. We treated failure as a thing that could be prevented, should be prevented. We treated people like they were responsible for, causing outages. And it led to this very masochistic sort of on-call culture. I think of these as like our glass castles, right? And ops had a lot of blame to go to ops. We were very hostile to people who wanted to do our experiment because we were so afraid of people breaking things. And so we're like, engineers, let's stay out. And we kind of have come to the end of the line of that sort of architecture model. And if we look at, microservices, well, the technical causes we have here are many storage systems, many services, like many everything. And almost every time you get alerted, it's something new. Like there are very few repeating things that just happen over and over again predictably. Instead, like, we've moved, it's like we used to have a process in the monolith that we could trace, right? Well, now we can't trace that process anymore because it hops the network so many times. And so we've had to expose, the inner workings of the application to the realm of operations. And the socio effects of these systems are that we befriend our failures and treat deploys as things that are not just off and on, black, white, blue, green, but they're shades of gray. A deploy is just the beginning of gaining confidence in your code, right? You might have 5 or 6 different versions running in production, and that's fine. All of the stuff about stepping through your code, well, you can't do that anymore. So we've had to bring so much of the instrumentation into the realm of operations, so you can debug methodically by following the crumbs. And there's been a real push towards making on-call much more sustainable and humane. I think of this like a playground, right? We build software ownership is where you build it, you run it. It's robust, it's resilient, built for experimentation, for testing and production, right? Like you let your kid play on the playground, you expect they might bloody their nose, but you don't expect them to die, right? Because there are all of these guardrails all around. And that's what we need to build into production systems, right? Developers should be free to go and play. They should be free to go and experiment. They should be free to go and find their bugs in production because that's really the only place that most bugs ever show up with microservices. And we need to build those guardrails so that they can do so safely, so that there's a blast radius and they can only break it so much. So where are we going? Like, here's the dirty little secret. The next generation of systems won't actually be built and run by burned out, exhausted people or command and control teams. It can't actually be done, right? They've become much too complicated, too hard. You can't just clock in, clock out, follow a runbook, follow a playbook, do the prescribed steps. It actually requires your full creative self to show up for work. You can no longer just model these systems trivially in your head and lead to the solution. And if you try, you'll be readily outcompeted by people with better tools or sharper focus, or teams who can do more with less. Because the bigger your team gets, the more friction you've added, the more gates there are. Our systems are incredibly emergent and unpredictable, and just figuring out the problems on a daily basis really does take our full creative selves, which is why your labor is a scarce and precious resource. We all have to be mercenaries at times, like no arguments there. But as engineers, we're creators. We conjure up new solutions, technologies, products, and visions out of thin air. Like being a software engineer is the closest thing this world has ever seen to being a magician or a sorcerer. And we have a real responsibility to factor that in when we decide to work. You have a powerful voice at the institutions that you choose to work at. You should use it to advocate for those who don't. Use it to push for equality, right? Don't talk smack about our peers in marketing or sales. Don't lord it over the other roles. And you only get one career. Seek out high-performing teams or do your best to build a high-performing team out of your own. Don't give up. I feel like the biggest obstacle that we face in trying to, push more people to do observability or trying to, push more people to, care about this stuff is just that people have given up. People feel like it's not for them. They feel like they don't get to have nice things. This is just a Silicon Valley thing. That's not fucking true. You only get one career. Spend as much of that time doing creative labor as possible. Join teams that will let you do as much creative labor as possible so that you spend more time learning and building, not mired in tech debt and shitty, wasteful processes. I feel like we're finally at a point where all the stars are kind of pointed in the right direction. That this is why I was talking about, the glass castle versus the playground. Like the technical underpinnings of our industry are aligned to, point us in a direction where we can do more creative labor and less repetitive bullshit. And this is for you. This is for all of us. We have a real opportunity here to make things better. So let's do it. That's it.
Really inspiring. Thank you. Wow. What do you think? Do you want to take questions now, or you can hang afterwards and then both of you answer questions?
I'm happy to take questions now.
Anybody?
My computer is catching up. There we go.
Is it on the mic or chatting?
Either way.
Either way.
Okay, cool. I have my kids here, so one of them might scream or something. That's okay.
Sorry.
I like the idea that you're pushing toward focus on the team and stuff. I'm in a situation where there's so much demand on me to drive the team. We already pushed production a lot a day. Like we are really into this. DevOps, we already been through this DevOps cycle a year ago. But I'm in a team I'm in a platform team, and we have stream aligned teams, right? So I'm all in platform from the topology of books. But I find it really hard to push this narrative of elite teams into my team because I have a lot of new graduates, and it's so hard. I wonder if I don't know how to take it to push them forward toward an elite, and also I don't want to be selfish. Sorry.
I don't like the term elite. I find it very elitist, honestly. Sorry, go ahead.
In this regard. I know I'm against the elite too, idea of elite all over the world, but it's again in this regard only.
Yeah, no, sorry, I cut you off. Please go ahead. What was the second thing?
No, it's only this. Like, how would it be taking the platform teams, or somebody called them developer productivity teams?
Yeah.
They have many. I don't want to take all of the time here. They have many questions.
Yeah.
But this is my
so the problem that you're saying is that your team isn't interested in this sort of thing?
My team is a platform team, the team that links tools, all the CI/CD.
Yeah.
And we're lacking so much in this domain. So how to get the team up to speed is my mission.
How to get the team up to speed? That's a very big question. I'm not sure how to answer that, Liz.
Why don't you watch my talk and find out? I actually have a 4-step recipe. It's super easy.
Okay.
To me, it sounds like a silo. Ibrahim, to me it sounds like a silo that you have two teams doing things in parallel. And then often, like with the lead team, I also don't like that word. It's like a rock star. These words, like
Yeah.
kids don't do what you tell them to do, but they do what you do. So by behaving in such a way, you'll get others to follow and others to drop off. So
Yeah.
everything is management.
It also is the case that if you have a team that's mostly made up of new grads, right, like they're also like not jaded, not bitter, right? Like you can kind of help show them the right way from the start rather than having to get them to unlearn habits, right? So I think it's an opportunity in a lot of ways.
Yeah. Yeah, I would agree. I think that, like, with junior folks or new early career folks, honestly, they're just imitating, right? And so whatever you care about, they will then care about. So if you set and this is where I feel like a really, really powerful lever is the on-call stuff, because, if people are getting paged a lot, then this is a really great opportunity for you to show them that systems don't have to be that way, right?
Thank you.
Can I
Mhm.
can I ask a question?
Yeah.
So I have recently listened to some number of videos about something that came out there is called Pareto distribution. The point is that in very many processes, not necessarily even with people, it's often in nature. And when you're talking about people, when group of people doing something, the empirical law that emerges is that square root of people doing half the work. So if you have 10 people, 3 will do half the work. If you have 100 people, 10 will be doing half the work. And from the rest of the people, they will follow the same. So they will be super productive few that will do most of the work. In the people that are the rest of them will partition according to the same empirical law. So my question is, when you are describing those elite teams, is it actually fact that all of the people in such teams are really performing on the same elite level, or there is within those teams still partitioning into those who are super productive and those who are less productive, but because the team is super elite, then, well, maybe their less productivity is more than magnitude than in other teams, but still.
I feel very weird about that question. Like, first of all, it's unknowable. Like, we don't have that data. Second of all, on a high performing team, the ones that I've been on have not followed that pattern at all. And I have experienced that being around other high performing people inspires you to do your best work. And but I also think that it doesn't always look the same. Like, some people might be code producing beasts, just like all the code. I've worked with some people who are more like the type who, they might write 6 lines of code in a quarter, but save the company $10 million doing it, right? Like, how do you compare that? Those are very different archetypes. Are they valuable to you? It depends, right? Like, maybe the person who's writing shit tons of code is actually introducing a lot of bugs. Maybe that, I feel like very deepness of these laws that just, like, because how do you manage productivity? How do you measure productivity is such a controversial topic. I feel like working around people that are high performers has only ever been inspiring to me and the people that I know.
Bertie, what's the new value that we have? It's we polish each other like diamonds, right?
Yeah. Yeah.
I think, I really think that Honeycomb has made me a much better engineer, much, much better than I could have ever been at Google. We have a question in the chat about what the most important hard skills are that are not code writing related. Like, what makes for a great SRE or a great DevOps engineer?
What's a hard skill?
Ruslan?
What's a hard skill? And what do you mean by hard skills?
I normally hear that contrasted with soft skills like, communication and empathy, right? Like,
So, hard skills that a person needs to get into high performing teams. I don't think that this is like, I think that my point is that high performing teams are just like other teams. Like, some of the best engineers I know are not on high performing teams. You know, like it's about the characteristics of the system that allow the individuals who are on that system, who are working on that system, to be high performing. There are characteristics, there are functions of the tooling and the you know, it's like okay, so example, you know, if you know, if there is an engineer at Stripe right now who is, you know, mediocre or whatever, writing code at this rate or whatever, and they join Honeycomb and their productivity shoots up to, you know, they're shipping twice a day or whatever. They didn't become a better engineer in a system that, you know, makes their code go live instantly and has a lot of, you know, safeguards checked in. And, you know, it's just like, I don't think that you need better skills to get onto a better team. I think that my entire point is that that's not the way it works. Interviewing and, I mean, the whole question of interviewing and skills that you need to be hired in tech is so, anyway, I think it's really just rolling the dice. But I don't think it's any different than the skills you need to join any other team. They're not better engineers, is my point.
Mm-hmm. So
I
Adrian Coft was a while back he's at Amazon. He was the one behind Netflix training. So he was asked by CIOs of the banks, where did you find those superstars, those elites? And he joked immediately, like he says, we took them from you and got out of the way. So you empower people, like everybody wants to.
Yeah.
You just have to micromanage them and, I don't know, let them fly.
A thing that often happens is, you know, engineers often know exactly what they want to do to speed up the velocity of delivery, but they're being leaned on to write more features constantly. And, you know, infrastructure type work, operations type work is often seen as, you know, nice to have, not as, you know, a force multiplier. Sorry, Liz, were you going to say something?
Yeah, the thing I was going to say is, I suspect that this is coming from someone with the perspective of like, hey, I'm an engineer, I want to join one of those high-performing teams. How do I attract the attention of that high-performing team, or how do I get an interview? Right, and my answer to that is, high-performing teams don't care about specific technologies. High-performing teams care about adaptability and curiosity, which are in a technical sense, right? Like, not, you know, yes, you know, we care about soft skills, we care about communication, right? Like, of course, those are givens, but if you're looking for, like, what technical skills can I work on? My answer is, like, look at a variety of systems, be able to kind of break down a variety of systems, be able to understand at a glance, right? Like, if you develop that skill set, you will thrive anywhere. You will be an asset to any team that you join, and kind of some of the quote-unquote top teams of the world will be really competing for you.
Yeah. Yeah, I would agree with that. I think that's great. Thanks, Liz. That's a very good insight. I think that just like even thinking, talking, writing about tuning sociotechnical systems, I think there's a dearth of that material right now. People are just starting to talk about it in those terms. We're just like talking about how, you know, if you take your team from, you know, shipping once a month to shipping, you know, 5 times a day, and then write a Medium article about how you got there, I think that would get the attention of the people who you want.
Cool. Well, shall we go ahead and move on to part 2, kind of how to apply this in practice, Liz's 4-step recipe? Because I think that'll answer a lot of the remaining questions. And then after that, kind of Charity and I can take questions about any of the material that we've presented so far. Sound good?
Sounds great.
Great. Let's go ahead and dive in then. Hi, so I'm Liz Fong Jones. I am a principal developer advocate at Honeycomb, and I work very closely with Charity. So Charity kind of shared with you why you as an engineer should care about kind of working on a high-performing team, what that high-performing team looks like. But I know some of you here are managers, right? Who are managers or tech leads who care about the health of your team and are asking, how can I get some of these practices onto my team? So here's what the pitch to your stakeholders looks like, right? Like, and to your team. We write code to solve problems, and our code alone doesn't accomplish the job, right? Like, we have to care about the operations side and pushing it all the way through until end users are experiencing our code and are experiencing that impact. Otherwise, we haven't accomplished a damn thing, right? So that's kind of the reason why you and your engineering teams and your stakeholders should care about making sure that your code makes it to production and does so in a reliable fashion. And we've introduced a lot of kind of steps in that process, right? Like we've introduced things like Kubernetes, we've introduced continuous integration, continuous delivery, right? Like we've introduced all these technologies. And our tooling has not necessarily kept up for understanding technologies, right? Like we've introduced so many pieces of tooling for building, right? For building more and more complicated microservices with more and more dependencies, right? But it's harder and harder to understand what's actually happening. And the same thing is true as you scale up horizontally, right? Like it used to be you could pin things down to one or two individual machines. That doesn't really work anymore when you're running a workload across many different containers. So how can we deal with this complexity spiral where you can't really understand and contain what's happening on your code and where your engineers are kind of burning out and struggling and flailing? So how we tend to deal with this is reflecting back on what uptime means and kind of adapting our notion of what it means. It used to be that, Charity and I were both Charity was describing earlier kind of the old lamp stack, right? In my case, it was not a lamp stack. It was a Java game server and a MySQL database, right? Same deal, right? Like, server up, great, server down, bad. We don't live in that world anymore. We often have to be reactive in response to user complaints, and we ideally like to be a little bit more proactive and measured about our responses. And there's a lot of pressure on our teams, right? We have to think about how do I handle, how do I handle developing features? How do I handle reliability and break fix? And then how do I handle improving reliability? Those are three separate work streams that we have to deal with every day. So instead of adding more complexity and kind of exhausting our heroes and right, like having this one person on your team who's the expert who understands everything and no one else understands anything, right? Like we have to pick a different strategy. So this is the recipe that I encourage you to follow. So the first thing is do not buy DevOps in a box. As Charlie said, tools can help you in developing a good culture, but tools are not the entirety of the culture. Because if you do things like, deploy CI/CD and you say, hey, we want to ship shit faster, right? You ship shit faster, right? It's not actually great unless you impose quality constraints on your delivery. Similarly, we need to kind of not necessarily make it so you can blow away all of your production infrastructure with one change with infrastructure as code. But I think, Charlie said earlier, you should put your developers on call and you should make them not scared for production. I think a lot of people, unfortunately, misinterpret what Charity says and put their developers on call and say, we're going to have this magic feedback loop that instantly solves things without actually giving the developers tools to code. And that leads to people getting paged all the time at 3 a.m., right? Getting paged multiple times per week, multiple times per day. And engineers get really grumpy and they shut those alerts off, or they quit your team when you say, hey, I'm going to make everyone go on, right? So we've got to come up with a better solution for this, right? How do we give people both the empowerment of being on call, but also the tools to solve the problems they encounter while they're on call? So people, unfortunately, lean towards, let's just throw more dashboards at it, right? Like, sorry for the dig, Datadog, but like, let's give everyone a Datadog account and we're going to, set up all these dashboards for you. And now you're on call and it's 2 a.m. and you're bleary-eyed staring at, 20 different pages of graphs, each with 20 graphs on it, which only wiggle at the same time as the other line, right? Like, human beings are not really meant to ingest data this way, right? It doesn't help us be better engineers. It doesn't help us debug when we have this situation. And while you're staring at these graphs, the incidents are taking forever to fix and customers are waiting and they're not happy. To call up your tech lead, hey, Charity, I know, it's me again. I'm sorry, it's 3 a.m. Oh, right, you're still awake, right? But that doesn't work. That doesn't scale. Charity can't take a vacation now, right? Charity can't retire, right? Like, that's not okay. And Charity gives me a magical solution. I got back to sleep. It's 4 a.m. We go to work the next day. We try to implement a fix. We try to push it out, and it gets rolled back along with 1,000 other commits, right? Not super happy fun times. This is what we call a state of operational overload, where there's no time to do projects, and you don't necessarily have a plan if you find an hour or two lying around. So a lot of teams in this situation find that they're really struggling to hold on, that they don't really understand where's the light at the end of the tunnel, how do I get out of this? So if tools won't solve this, then what will? As Curtis said in her talk, what we need is a socio-technical solution instead that emphasizes the people as well as the technology. So the tools aren't magical, right? Like, they can remind you to do things, they can kind of help you do something you've already committed to do, but if you are dead set against doing something, like if you have a blameful culture, you're never going to be able to reverse a blameful culture with a tool, right? You kind of have to work on that with kind of leading by example, not blaming people and so on and so forth. So people, culture, and process is the name of the game, not tools. And this is what I describe as production excellence, not just production ownership, but excellence in production. So how do we make our systems both reliable and operable, friendly to the people who operate the systems? We have to plan, we have to measure and act on what matters, and we have to involve people from a range of job functions who are our stakeholders, not just the engineering teams. And we have to build a psychologically safe environment for people to do that. So what are the 4 steps involved in production excellence? First of all, you need to know when things are too broken. Secondly, you need to be able to debug those systems. Thirdly, you have to be able to collaborate across teams when debugging. And then fourth, you need to close that feedback loop and eliminate unnecessary complexity. That's the 4-step recipe for production excellence. So why did I say no when things are too broken? Well, our systems are always failing in microscopic ways. This is kind of the nature of microservices. So why don't we measure what too broken is instead of trying to aim for 100% all the time? So this is the service level indicator, which comes from the site reliability engineering practice. So SLIs and SLRs are common language. They're a technical mechanism for us to communicate the product requirement of reliability between us as engineering teams, product teams, and our stakeholders as customers. So what is an SLI made out of? Well, a service level indicator is made out of measuring events about our critical user journeys in their full context. Things like how long did the request take, which customers did it cover, which build ID did it run through, and other properties such as what was the actual query that someone ran. And is the event good or bad? Does it reflect a good or bad customer experience? Does it meet our customers' needs? And this is where reaching out to product management or user experience researchers can be really helpful. Or if you're not sure, dog with your own product and just slow it down until it feels sluggish, and that's your threshold. So we need to find a rule for categorizing events as good or bad. For instance, the event is successful if it was an HTTP 200 that took less than 100 milliseconds. So for instance, this is one of our real service level indicators. If I have a query that takes more than 10 seconds or returns partial data, I have failed. Otherwise, I have succeeded. And then we have to think about how many eligible events we saw, right? We don't care about your friendly neighborhood botnet. We don't care about your competitor scraping you, right? We just care about real user transactions. So filtering it down, so we're only looking at, for instance, real user interactive queries and not automatically generated queries from our alerting system. So then you have your availability target, which is the number of good events divided by number of eligible events. And that enables you to set a target service level objective, which you're trying to achieve, which is your agreement with your product team of what reliability means to your customers. And I can't just say, hey, Charity, like we were 100% down yesterday, but that's okay. We're 100% up today, right? Like Charity would laugh me out the room, right? So we need to set a window like 30 or 90 days and a realistic target. For instance, 99.9% of events are good over the past 30-day window. So this is how we might describe it, right? Like the service level indicator is HTTP 200 less than 100 milliseconds, and we're aiming for a 7 or 30-day window and 99.5 reliability. Why not 100%? Well, when you aim for excessive nines, right, like that means that you are throwing away money and throwing away product velocity in pursuit of something that your customers are not going to notice, right? Your customers are probably, unless you're, operating 911, they're probably not going to notice that you had a 5 millisecond outage, right? So a good SLO barely keeps your users happy and allows you to maintain as high of a product velocity as possible while keeping your users happy. So what do we do with this? Well, first of all, we can decrease alerting noise with SLOs. Instead of alerting on every single possible cause of an outage, instead we alert only when we exhaust our error budget. If I'm aiming for 99.9% of events to be successful, that means 0.1 are allowed to fail. So if I'm serving 1 million requests per month, I'm allowed to have 1,000 of them fail per month. And if I'm burning through 100 per hour, I'm going to run out in 10 hours. I should wake someone up. If I'm burning through 100 per day, that means that I can have 10 days before I exhaust my error budget. That's fine. I can wait until the next working day. So this is a real outage that we had, in which our service level objective alerted us that we are dropping user events. And even our black box monitoring did not pick it up because our black box monitoring was waiting for 2 consecutive requests to fail, whereas this was measuring the overall health of our service. The second thing that we can do beyond just decreasing alerting noise is to make data-driven business decisions so that Charity can decide, are we under or over investing in reliability right now? If we have too much excess reliability, we can innovate faster. We can take more risks in iterating on our software development and in iterating on our infrastructure. For instance, using feature flags. But conversely, if you've had a bunch of bad outages, it provides Charity and Megan, our product manager, the signal they need to say, you know what, we need to defer doing product features until we get reliability under control. This doesn't mean you have to be perfect, it just means that you have to be good enough. That you can adjust over time, starting by measuring, for instance, load balancer logs, and then implementing a more sophisticated APM-based SLO approach. And over time, remember, your users are always right. Like, if your users are complaining but your SLO is green, your SLO is wrong. Conversely, if your SLO says things are broken but no one's actually calling the call center, then maybe your SLO is too stringent. So only to learn what matters. And that's kind of half the picture of why you need to pursue service level objectives in order to make your engineers' lives humane. But it's half the picture because you also need to be able to debug those systems with observability, as Charity said. So our outages are never identical, right? Like in the LAMP world, you can always assume that it was going to be MySQL, right? Like it's always MySQL, right? That's not true today, right? We have diverse kinds of failures, and we can't predict in advance how things are going to fail, or else we wouldn't have written the bug in the first place. So instead, we need to be able to debug novel cases in production. As Charity has said, right, like you cannot overinvest in your, it is important for you not to overinvest in your staging environments. Because your staging environments are an imperfect replication of production, and they're never going to be able to fully reproduce every production issue. So instead, why not invest in being able to debug and understand what's happening in production today so your customers don't have to wait weeks for you to reproduce? Don't silo your data. Make sure that people are using the same tooling across your organization, and really empower them to ask new questions without pushing code. Allow them to form and test hypotheses about what is happening inside of the system. For instance, having them be able to say, you know what, that particular slowness looks weird. Honeycomb, show me what's slow about that particular set of queries. And really dive into your data and ask new questions and constantly be iterating on your queries rather than feeling like you're trapped to only being able to investigate using a fixed set of dashboards. So all of this is to say that our services have to be observable, that we have to be able to understand the inner workings of the service without pushing new code just by using the telemetry they're emitting. This requires us to emit wide events that are in context. As Charity said, there are a number of properties of an observable system that really depend upon high cardinality data, and depend upon being able to visualize not just individual log lines, but instead the relationships between trace spans. So you understand where are we spending our allocation of time during this request. And can we explain the variance? Can we understand what distinguishes a slow query from a fast query, or a query failing our SLI from a query succeeding at our SLI? And better yet, why is it that we have to be on call at 3 a.m. watching it fail, and not able to debug if we don't catch it happening in real time? Why can we not mitigate the impact and use the telemetry signals that were emitted during the incident? Why can we not look at it at 8 a.m. from the comfort of our desk with a cup of coffee instead of in the middle of the night at 3 a.m.? Observability is not just break fix. You know, Charity and I developed a maturity model together that talks not just about operational resilience, but also about weaving observability in as part of an observability-driven development practice. Are you adding telemetry and instrumentation as you write the code in the first place, alongside your tests, rather than shoehorning it in after the fact? Do you have visibility into your release pipelines so you understand where the time is being spent? Do you have insight into what users are doing in your product? And do you have an idea of where the scary areas of your product are? What's the dependency relationship of your services? How are you actually understanding where there's a lack of instrumentation? And the other misconception I want to clear up is observability is not just the data. You often hear people talking about, oh, observability is logs, traces, and metrics, right? Like, those are data formats. It turns out that observability is a socio-technical capability of whether your engineers can ask questions about their system. So therefore, we need to make sure that our engineers have an ergonomic experience instrumenting their code, that they can store the data in a cost-effective manner, and so they can query that data and get answers to their actual questions and not just what the dashboard author thought they want to ask. So SLOs and observability go together because they help you understand both when your system is too broken and how and why it's broken so you can get it back working again. But we also have to think about the other kind of fuzzy socio-technical aspects of collaboration. Because we cannot be heroes, right? We cannot work alone. And we really have to work across job functions, for instance, with customer success and with the people who provide our cloud services. So really practice together, right? Practice chaos engineering, practice game days, and really make sure that people feel safe to say, hi, I think it was my change who broke the build, rather than hiding under the desk and hoping that no one notices that their change broke the build. help people revisit and understand what other people query so that they can have an easier time learning how to use the tooling and to get insights from what other people are doing. Make sure that you're having good on-call practices to share the load, right? As Charlie said, no one person should get woken up in the middle of the night more than 1 or 2 times per year. It's okay for a middle of the night page to happen maybe once a week, right? As long as that everyone is rotating week on week. And document the right amount so that people understand in the middle of a panic, what do I do to make the pain stop? And then I can go back and debug it later. So fix your hero culture, really share that knowledge between teams and use the same platforms and tools so that everyone has the same unified view of instrumentation and data, rather than saying, hey, Cherry, that's your team's fault. Like, the dashboard's agreeing on my side, right? Like, let's make sure we have a shared view of what's happening in production. And express thankfulness to people, right? Thank people for raising questions. Thank people for going above and beyond. Reward curiosity and teamwork from your teammates. But I think there's another important element, which is that we're not just working with our current selves, we're working with our past and future selves too. So leave yourselves traps, not cookies, right? Leave yourselves documentation, leave yourselves query histories that you can understand what you did in the past. Because when it comes time to write that retrospective, you'll be really thankful that you wrote it down. The other bit is we can be a little bit more proactive than just responding to individual outages. Because outages do have common factors that rhyme, right? Like any systems engineer like myself or Charlie, who's been around the industry for a decade, knows the MySQL database eventually fails, right? Rule 0, the MySQL database always fails. So what?
Is it my internet or I lost Liz?
I can hear you.
Yeah, Liz, you
Yeah,
lost
they would watch Liz now.
Liz, Charity,
Yep.
can you ping her? You have her on Slack.
Yeah, I will pick her.
So at least we know the slide. Yeah. See, we thought your internet was bad, and now.
I know.
Well, I know Vancouver's had a lot of windstorms just like Toronto had yesterday, so hopefully she hasn't lost power.
Ooh. Ooh. There is a dial-in number. Maybe she can call in at least.
So this is where we see the difference between a little bit earlier when we had the intermittent drops, and now we have the full outage.
We're just testing your.
I swear between Terry and me, we're fucking. You all hear me now?
Yes,
Yep.
yes.
Yes, welcome back.
Let's go.
What was weird was I could hear you, and that helped me determine that I was actually having a problem. So thank you. Like my connection broke upstream, but not downstream. Okay, so as I was saying, risk analysis helps us plan. It's eventually going to be the MySQL database failing. You don't have control over when it happens, but you have control over how bad it is. So think about, does the MySQL database going down impact everyone or just 2% of users? Does the MySQL database going down affect everyone for 2 hours or just for 2 minutes? Right? Those are all things that we have control over. So we can do things like shard our database, right? We can do things like have automatic failover to mitigate some of those risks. So we need to identify which risks are the most significant and then mitigate them. And that's how we decomplexify and get rid of some of that spaghetti. So remember that we said what the acceptable amount of risk was for our system, the service level objective. So if something is going to consume 50% of your error budget, and that's just from a cause that you know about, you'd better address it so that you leave plenty of room for unknown unknowns. And that helps you make the business case to fix them. If you go to a product manager and you say, we agreed we were going to be 99.9% reliable, but instead we're going to be 99.8% reliable unless we fix this, right? Like that's really compelling. And really priorities completing that work, right? We write a lot of retrospectives at Honeycomb, but we don't do every single action item from them. We do only the ones that matter. We do only the ones that we think are going to have a meaningful impact upon our service level objectives. So don't waste your time chrome polishing, right? Like do things as a infrastructure engineer that are responsive to the needs of your business. But there are 2 things that I think are really important. If you have a lack of observability, that is systematic risk, right? That makes the business case, right? Like if every outage you have takes 30 minutes or 2 hours or 2 days longer because people cannot see what the heck is going on, that's a systematic risk, and that is going to blow every single error budget that you have. Secondly, if you don't collaborate, right, like if your customer success team, the last time they called the engineering team, were told that's a problem between keyboard and share, go away, right? Like the next time they're not going to report that outage, and then you'll take, days or weeks or months to find out that something's a problem for a customer. So you don't have to be a hero in order to achieve production excellence, but you do have to embrace this idea of observability-driven development and of culture first, then tools. So up until 2 months ago, Honeycomb was a dozen product and infrastructure engineers. Now we're about double that, but like for a while, a good long while, it was just a dozen engineers. And people said, I thought Honeycomb had 100 engineers, right? Like, and that's not true. It's just a dozen of us. And our goal is to make systems humane to run by ingesting your telemetry data, enable you to explore that data, and empowering you as an engineer. And yes, we do deploy on Fridays, every single Friday. In fact, we deploy up to a dozen times per day, every single day of the week, including Fridays, but usually not on weekends. This is a real graph of the number of distinct build IDs running in production, broken down by day over the past year or so. And what's our recipe for being able to do this, to be able to move fast with high reliability? It's observability-driven development. So we start with lead time, right? Like we start by decreasing the amount of time that it takes someone to deploy a change to production. We make sure that our builds take less than 10 minutes, and every time it takes longer than 10 minutes, we stare at why is the build so slow, and then optimize that bottleneck. So at worst, it takes me 30 minutes to get the build to pass. It takes me an hour for someone on my team to look at my change, because we do view peer review as very, very important. And then once an hour, whatever is at the latest state of main branch gets pushed out. So at worst, it takes us 3 hours to push out a change, which means that state is always fresh in your head. You know what you changed, and you watch it go out to production. You don't just push and run it at 5 p.m., no matter which day of the week it is. So our infrastructure is set up to go out every hour if there's a change, and we aim for no more than 1 or 2 new commits per build artifact. But as we go beyond 2 dozen engineers, we're finding that hourly is no longer working for us, and we need to deploy more often than even once per hour. Our change fail rate also has gone way down. Because of the fact that we use feature flags, and because of the fact that we have the ability to build new releases quickly, less than 0.1% of our changes require anything more than a rollback or a flag flip. And our time to restore is really, really quick, because in the worst case, if we need to fix forward, it's just going to take us 20 minutes. 10 minutes to go ahead and build the new release, and then another 10 minutes to push it out to all production. So we instrument as we code. Yes, the deploy rate should be tied to the number of engineers. It is not right now, right? Like we are capped now at 1 deploy per hour, and that's kind of a pain point that we recognize we need to fix that we didn't previously have when we were only a dozen engineers. So we instrument as we code, right? Like we add telemetry data into that's emitted by the code that we write, so we can verify how it's going to behave in production. We do functional and visual testing, and we design for feature flag deployment so we can turn off individual features without rolling back the entire release. And we practice automated integration so that we are relatively confident that at least if something smoke tests, that it's going to mostly run successfully, and that way it makes the code reviewer's job easier. And when we do those automated smoke tests, we aim for it to, as I said, take less than 10 minutes. So here is a 15-minute build where we determined that we needed to speed up the JavaScript step by caching some of those dependencies more aggressively. This is the kind of continuous investment in tooling that makes it possible to go fast. When we do change review, humans look at the changes not just for testability, but for observability. Did you add instrumentation or not? How are you going to understand this in production? Those are some of the questions that we cover either in our head or out loud when we're doing peer review. And let's give the robot a high five as well, right? Like humans have much less work to do if they're already convinced that it's more or less correct because the robots and the tests have caught any major issues. When the button turns green, we merge, and then it automatically gets pushed out on the next hour. And if we do need to revert, we can easily revert to a previous artifact. But the most important thing out of all those things is really observing behavior in production, right? I don't care whether it's Wednesday at 5 p.m. or Friday at 5 p.m. I'm not pushing a change, right? If I cannot stick around to observe it for the next 2 hours. Production is where our customers observe their data, but we have a dogfood environment where we observe our production. And then there's also a kibble environment that observes dogfood. So this way, we can understand what are real users doing with the service, and is it performant enough? And if it's not performant enough, why? So that's how 12 engineers have deployed 12 times a day. And this is how we're hoping eventually, if we get rid of the hourly bottleneck, that 24 engineers are deployed 24 times per day. So, you know, buy the right tools, for instance, like Honeycomb, but like season your soup with your alphabet soup with some production excellence culture, right? As Jerry likes to say, you know, on-call is a spice, right? You know, production excellence is a spice, right? You know, you want to dump a little bit in, right? Like you don't want to like dump the entire thing of salt in, but also bland soup is really terrible. So production excellence really helps you achieve a higher degree on all those door metrics because you know when things are too broken, you can debug things together, you can collaborate across teams, and you can really fix and close those feedback loops. And, you know, I'm not lying, right? Like, we actually do this every day, right? Like, this is dog food. And we have service level indicators that tell us, for instance, are we causing too many users' queries to fail? Which customers are having the most pain right now? Can I understand for that particular set of queries that are persistently failing, why is it that they're failing? What's going on with them? And then I can even dig into each specific dimension or look at individual traces, right? For instance, I can see here that we have some SDK users who are sending request bodies that are too large. Or for instance, I can say, you know what? Show me a trace exemplifying this particular slow query that took a long time. Why is it so slow? Right? This is possible because we've really invested in instrumenting our code. So we understand out of the time it takes to ingest an event into Honeycomb, how much of it is spent on JSON parsing? How much of it is spent reading off the network versus actually writing the copy, right? These are all things that we can answer because we've invested the appropriate degree. And that's really important because it's a force multiplier. It enables us to go faster. So I think with that, Jerry and I will take questions. Unfortunately, I missed all of the questions that came in before the disconnect.
Thank you. Very impressive. So you see how we started with the theory and then ended up with practice. An example of Honeycomb. Impressive. So let's see the questions in the chat. Anybody?
See, do we define SLOs for each microservice or for the system as a whole? The SLOs are defined for each major kind of business line or kind of each major thing a user expects to do, right? So we have an SLO for, is it possible for someone to ingest events into Honeycomb, right? Has to be 99.99% reliable. We only get one shot at it. Or is it possible for someone to query Honeycomb, right? And for the results return in less than 10 seconds. Or does alerting run every minute and run successfully? Or does someone loading the Honeycomb homepage have results return in less than 3 seconds, right? If those are all service level objectives. It doesn't matter what the internal implementation details are. What matters is the critical user journey and how we measure it. The other question was hourly cadence to establish a schedule. Yep. The hourly cadence is because at the time it was the most practical to say, you know what, anything that lands by, 12 minutes past the hour, we'll make it to production. We'll make it to dog food at 33 past and we'll make it to production at 55 minutes, right? Now we need to be a little bit more sophisticated and have like a deployed pipeline, but we didn't before. We were just kind of automatically promoting things with time.
Can I ask a question?
Yeah, go for it.
So about instrumenting the code, is it auto-instrumentation that you turn existing logs or a developer needs to do something? Can you show example or just what?
Yeah, so automatic instrumentation will give you a skeleton, right? It'll tell you, what services are calling what other services, right? It'll tell you based off of, either your service mesh or your gRPC server, right? It tells you what calls are coming in. It does not give you any metadata, right? It doesn't tell you user-specific things, right? Like which customer is this? Or what was the payload, right? Like those are things that gRPC does not automatically send along. And that's where your engineers who wrote the code most recently have that state in their brain of what might be important, should be adding those fields to your traces. So you kind of have to have a mix of audio instrumentation and manual instrumentation to succeed. Charity, is there anything you want to add?
No, that's great.
So let's say you want to start with Honeycomb, so somebody would need to read some README guidelines how to instrument the code, like it's not just switching the logs to it.
You can use existing logs. We prefer people don't actually in general because a lot of existing logs are very messy. They have, for instance, more than one line per request, right? And you want to really bundle up everything that happened in the context of a request and send it all at once so you can cross-correlate. And that's not really true in an environment where you're sending kind of n-formatted data. So structured logs, yes, we can directly interpret, but we strongly prefer that you start with tracing, right? There are some excellent libraries, whether they could be Honeycomb's proprietary beelines or OpenTelemetry, that will handle setting up that scaffolding for you. And then if you find something is useful from your logs, you can attach it to a trace scan, right? So, we'd rather not, a lot previously, like, when I took Honeycomb a year and a half ago, people would be like, I send 3 terabytes per day to my Splunk cluster. How much is that going to cost me, right? And we would quote them, $13 gajillion, right? And right, like, we don't want the volume of your previous data to put you off, right? Instead, we want you to think about how many requests are you getting, right? And how can we help you get the most value and instrumentation out of that? So actually, we do not charge you by the number of distinct fields you send. We only charge you by the number of distinct events you send us.
So every company thinks that they are logging in metrics, and how do you go through the noise? And if my company is using AppDynamics or Splunk, how do you tell them? Like you mentioned Datadog, and I hear your point. But when I went to last train event, it was one of the tutorials, so people don't want to think about it. It's just observability. So can you speak about that, like Honeycomb observability versus the rest of the noise?
There are a lot of kind of imitation observability solutions, I'll say. There are a lot of solutions that are based around I mentioned these kind of 3 data types, right? A lot of vendors are selling you 3 distinct products, 1 per type, whereas what you actually want is something that combines those data together and allows you to slice and dice the data and get any format that you need. Whether, right, like you saw me go from service level objective, right, with lines to a heat map directly to a trace, right? Like that's the kind of visibility and ability to kind of dive in, asking questions, right? Like, so I'm not going to be down on individual products necessarily, so much as to say that you need to make sure that you have the right methodology that your teams are using instead of being passive consumers of dashboards. To have people be actively querying and asking questions and have that feel fluid and seamless.
Totally.
SRE, you build it, you run it. SRE, so this actually goes to the subject of what Charity and I are recruiting a role for right now, which is we are recruiting 1 SRE for Honeycomb, right? And their job is not to run the systems, right? We have engineering teams to do that, right? Who are the same people developing it. Instead, you build it, you run it, often has to be supported by SREs who consult, right? Who partner, who help you develop those reliability backbones across your company, right? What does a good retrospective practice look like for a company, right? What does our RPC framework for the company need to look like, right? Like those kinds of cross-cutting things are things that a platform engineering or SRE team should do while still having individual teams own and operate their services.
Sorry, so just to follow up on that, if I may. So is the idea that if you have an SRE and you build it, you run a culture, the engineering team is still the one getting woken up in the middle of the night?
Yes.
But during the course of development, they're relying on SRE expertise and knowledge to help guide them on how to build it well?
On how to build it, as well as even just having the defaults come correctly out of the box.
Okay, thank you.
Span granularity versus number of events. Start with one span per RPC. After you have 1 span per RPC, if you start seeing areas where you are like, oh my god, I don't understand what's happening inside this service, then create manual child spans. But in general, as long as you're creating a span whenever you have a call coming in, and whenever you issue a client call and it takes time somewhere else, that you have a span for that outbound call, then you're generally fine. Right, you want to make your spans as wide as possible, right, in terms of number of fields.
Wow. Anybody else? Guys, don't be intimidated. This is a unique opportunity. You have two of the brightest minds in the space at the same time.
Guidance on the typical sorts of things you stuff into an event. Yeah, we've written some docs on this and everything, but the answer is just like, honestly, anything. It's effectively free. It's actually free using Honeycomb. We charge only on the number of events, not the number of dimensions or anything, and it's effectively free even for us to store them. So like, if you want to toss in, I would start with any unique IDs. right? Anything that's high cardinality, anything that might help you find this needle in a haystack later on, right? Like shopping cart ID, user ID, all that stuff will be useful. Raw query, normalized query, source IP, destination IP. Some of the things that we do in the Honeycomb beelines is we automatically wrap every HTTP call and store, the timing information. We automatically wrap every database call, store like query and the execution time and all that stuff. Any call out to another service is going to be any variables, any sizes, anything like that. And like unlike with metrics where you often have to go back and do, another pass to like cut down the custom metric that you're capturing because it's too expensive. You don't need to do any of that pruning with this model because you can just throw it in and forget it. And at some point in the future, it might turn out to be the thing that you were looking for.
Only 39 did the form, so feel free to go in there. We're giving away, Manning is giving away 2 books on observability, telemetry really, and there are examples of Honeycomb in there. Any other questions? So people are afraid of vendor lock-in. So open telemetry would be kind of a way to be safe that they can move from you to anybody or from anybody to you. Is that so? Okay.
Yep. Correct.
Hey, I have a quick question here. So, well, maybe not that quick actually. So, how do we? I asked earlier about bootstrapping this kind of practice in the team, right? Like, how do you make a team care? So, if a team is overloaded with, we have to build feature X, Y, and Z, and you want to show them that they can own things themselves and they can, the customer can have a better experience. How do we start that in a busy team?
Well, putting people on call is a pretty big hammer because, if they're getting woken up, they will care. Honestly, I feel like engineers are born caring about this stuff. Like we all want to do a good job. We all want to do well. We all want to do well for our users. And it's just that some of us have had it drummed out of us. And I think that if you're putting a lot of time pressure on people to deliver features and you're not also like combining that with a focus on quality, not combining that with, giving people time to do things well, if you're not measuring quality, like it's hard to care about things you don't see. So if you aren't even measuring the impact on your users, another way to make people care is to put them in contact with their users, having conversation. There's nothing that makes you care more than, pairing with one of your users or seeing their pain close up.
There's that dopamine rush, right? Like when you see actual users using your feature in production, you want to get more of it, right? That screenshot I showed of the service level objective feature, right? Like we launched it, we looked to see what customers were doing, and it made my heart sing when I saw people actually using it.
And it makes you cringe if you watch them use it and there are bugs or problems or rough areas or it's not working well. Like that gets to you at a very deep and personal level. And then like Liz was just saying, like the dopamine rush of actually fixing it. Like if you can connect people with the consequences of their action, they naturally care. And if they don't care, it probably means that you aren't measuring or connecting them with the consequences of what they're doing.
Or it's taking too long, right? Like if I develop something and it takes, 3 months for it to reach production, like I'm going to have forgotten that I wrote it and there's no feedback loop to feeling good about having written it.
But that's exactly the point that attracted me to us, series. That's focused on users. It's not about us. It's not about where we run stuff. It's about measuring what's important for users and see they do. That's cool. Thank you. Okay, next. We don't have to stop now.
You all don't, but I do. So I'm going to go and eat my dinner once I starve.
Few more minutes. Couple more
The rest of your chat is shared.
Couple more questions and I'll do the draw while you're asking. So, Well,
a lot of this stuff is like inherited from each other too, like what you care about. Like if you join a new team, you kind of look around and see what other people care about. The job ladders, people care about the things that they know will lead to promotion. And if you have a culture where the only thing that gets people promoted or only thing that gets people recognized is, shipping features no matter what the quality is, then that's what people are going to care about. In general, you tend to get more of whatever you praise people for, whatever you recognize people for, you will get more of it. So if people aren't caring about quality, maybe that's a sign that you aren't showing that you care about it as a team.
I'm going through the list of the people so we can do the draw for the books. Any other questions, folks?
Yeah, I'll jump in there. So thanks a lot, Charity. So, obviously developer apathy is an issue. And, I'm not saying developers are naturally apathetic, but they become apathetic when they are inundated with, non-core functionality or functionality that is deemed important by potentially a party that is not necessarily privy to even what the users are asking for. So how do you manage that developer apathy when you're actually asking more of them in a situation like this, and it's totally justified what you're asking of them, but you have to help them see why that is justified?
Sorry, can you rephrase the question one more time?
I'm just saying that it's a challenge to manage the developers' apathy because they are inundated with so many requests on their time,
Right.
regardless of that focus. So how then bring those developers along in your journey and sell them on the value of this observability so that they can help articulate that as being implemented?
Well, that sounds like a lot of management leadership problem. Like if we all aren't on the same page, if people are getting like competing, they're hearing one thing from you and another thing from your manager, that's a leadership issue. When it comes to observability in particular, I've seen engineers get hooked on, they're driving in the dark right now. Like they literally can't see what they're doing. And I've never seen an engineer who didn't want to see what the fuck they're doing and do work better, right? If you can do more work, if you can find the answer more quickly, if you can build software more rapidly, if you can, build with increased confidence, you sometimes need to like lead them to water, but once they've drank from the well, like it's not a hard sell. One of the things that I think is interesting and like an artifact of making the shift from the monitoring world to like the observability world is that historically it's been the case that the debugger of last resort, like the person who knew the systems the best, was always the person who had been there the longest, right? Like because they have access to the library of outages in their head is the biggest, right? They can just sift through like, well, this happened 3 years ago on Christmas, and when you move to an observability model, that's no longer true. The best debuggers are the people who are the most curious, who spend the most time in the tool understanding their systems, who really enjoy this sort of work. And I find that it's such a democratizing, it's such an encouraging thing, like there's nothing more depressing than joining a team and knowing you can never catch up, or that you'll have to be there the longest before you know the system as well as other people, and I think that it's fundamentally it's an encouraging thing if you can empower them with the tools that can make them so much better at their job, so much better than without just having to stay long enough to have all the scar tissue. It's something that engineers really, really take to. And I do feel that like anytime that you're asking engineers to replace a tool or a best practice that they use, what you're offering them in return has to be an order of magnitude better. Not just twice as good, not just 50% as good, not just, it has to be an order of magnitude better for it to be worth it. And the difference between monitoring and observability is not an order of magnitude worth it for everyone. But I think that what you see in that from 7% to 20%, the elite teams, and I believe it's even bigger now. I think that what you're seeing, those teams that are becoming elite, quote unquote, are the ones that are are shifting their center of gravity and really embracing all in on, center of gravity is production, not pre-production, right? They're investing in observability, they're investing in feature flags, they're investing in tightening those deploy loops so that they can ship more often. They're investing in testing in production. They're investing in, the tooling, because that speeds that feedback loop up so much. You can learn so much faster. Everybody gets better at their job so much more quickly, and it's an intoxicating, it's a dizzying, it's an awesome thing to be a part of. It might take leadership to kick it off. You got to drive some people over to the well, but like once the team gets a taste of that, they're up and running. Like it's self-fulfilling and self-reinforcing because it's so exciting.
Awesome. Thank you so much.
And let's face it, the instrumentation is not a lot of work, right, when you're doing it as you go, Charity. It's more like if somebody said, here, go instrument these 30 libraries, sure, that'll be a bit of a downer. But if you're doing it as you're building stuff, you're building.
Yeah, and to get started, like with Honeycomb, you just install the library. You add the library, right? And that takes care of all of the default stuff. And then from then on, it's like a printf, right? You're like, oh, I'm going to printf this into the blob. And as you're going, that's what I was saying. Like, I just think of it like a headlamp, right? Like you install the libraries everywhere, that gives you basic observability everywhere. And then as you're debugging, as you're getting a page for something, you just fall into the habit of instrumenting first, right? Just like putting your headlamp on so you can see in front of you, right? Just like, oh, there's a problem. I'm going to add a little bit of instrumentation, and then I'm going to look at it, and then I'm going to see it. Instead of like trying to stare at your lines of code and just like understand it by looking at software, like that just doesn't work. Like you can debug so much more quickly and easily if you just add some instrumentation and look at it running in production, and it will make so much more sense than trying to like build castles in the sky in your brain.
Now this t-shirt of yours makes sense. A testing fraud.
Yeah, exactly.
Anybody else? We are after 8. I don't want to keep you too long, but this is also a unique opportunity. Any other questions? And how would people get to you? Like, can you put in the chat? Like, how do they get trial? Is there a trial of Honeycomb, or it's a contract? Like, how do they get started if they're curious?
Sure.
Well, on that note, I just want to say that I thought your sandbox on the website was fantastic. The fact that you could dig around and follow the little guide of how you dig down.
That's the link I just typed in there. And that's actually taken from one of our outages. We just took all of the telemetry from that data set from that outage. We put it up there so you can kind of follow the path, see if you can debug it quicker than we did.
I thought it's neat. Like, to me, that's more powerful than listening to a salesperson. If I want to know the process, I thought that was
But it's
fantastic.
overloaded. Like, I ignored you for years. Like, you at every Serverless conference, but it was, who's going to listen to logging, So I empathize. I like your talks, but they were not actionable until I fell in love with SRE, this user component
Yeah. Yeah. No, the thing I love about observability is it aligns you with your user, right? If you think about monitoring, it's been about, is the system healthy? Is the service healthy? But this is about, can my user get the resources that they need to execute from end to end? And it's just inherently, like, I like that shift.
And it's not easy to get started. Like, I compare it to Wordle maps. Like, when I listen to Simon and you, like, yes, do it. But then you want to try to put Wordle maps or to identify someone. It's not easy. So we need some kind of hand-holding guidance. Is that what Honeycomb provides, or a crash course always?
Honeycomb does.
Okay.
Yeah, it really is that easy. We have on our website, there's like a sample app you could import, and then it walks you through adding the instrumentation and everything. Or you can just like take the gem or the Go library or whatever, just install it, and then show up to Liz's office hours if you have any problems. It's that easy. It should be that easy.
That's cool. Oh my God! So let's do the draw. Like, unless you can change your mind about questions, folks. So this is the list of the people I imported into this wheel of names. Anybody else? Charity, did you see that book? You want it as well?
Oh no, thanks.
Okay. Okay. So let's try it. You have to be here in order. I pasted everybody, like 39 names. Okay. Simon, are you with us? If you're not
Yes,
here,
I'm here.
okay. So So this time we're not going to allow you to choose any book. I would like people to start be more proficient on observability, and there are some tutorials on using Honeycomb and other things in this book. So ping me, please. I don't have your contact info, so send me your email. So let's do one more. I've already name. Please paste your email in the chat, and then who's the next winner? Hey, Harold, are you here?
Yes, I am.
That's beautiful. Thank you for being here. You're a regular now. I hope
Yes.
you will like this book. You can put it to your proud to use immediately.
Awesome. Awesome.
Cool. I have your email address.
Great event this evening.
Thank you. Thank you so much. We were really lucky like that. It's all stars aligned.
Yeah.
And so this is the first time COVID helped, because I did try to get you charity here, but it was problem us funding the hotel, and we're non-profit. I had no money to make sure you stay in Toronto over the weekend. So thank you for jumping in this way, and Liz as well.
Absolutely.
And I look forward to learning more about Honeycomb. Just kind of so can you tell us more how company started? Like, that's something unusual about that as well. Female founders, female VCs. We have Linda here. Is that correct? I read it somewhere, I think.
No female VCs. No.
No, okay.
Christine and I were both engineers at Parse, and the experience I had at Parse was companies going down all the time. I tried every tool out there, every monitoring, logging, APM tool. None of them solved my problems, and it made me angry. And so I used this tool called Scuba at Facebook, and it dropped the amount of time it took for me to understand what was happening from like open-ended days, maybe never, to like seconds every time. And I didn't want to live without it. So like I fully believed that we would fail, but I figured, well, VCs were like pursuing me after Facebook and after earning me some money, and I was like, well, fine, we'll build the tool, and then I can open source it when we fail, so I won't have to live without it. And we keep not failing, so.
It's awesome. Thank you for going around and spreading the word. So how do they say it? Teacher will come, student is ready. So we are ready now. Thank you. Anybody?
Absolutely.
Want to comment off?
I think everybody's dropping off.
So
It's great to see you.
Thank you so much.
The slide deck, and then ask Liz as well. I will merge it with my.
I can do that.
My recording failed, so I'm hoping that some of you recorded. Email me the recording, whatever you have, Dropbox or Google Drive, whatever recorded, email it to me so I can edit it and try to upload it to user group channel. So thanks.
Sounds good.
Do the best.
Right.
Look forward to learning from you and reading that book. Whatever you're writing now.
Thank you.
Ciao. Thank you. Stay safe. See you next time.
Thank you, everyone. Thank you.
Thank you. John, thank you.
Yeah, no worries. No, that was fantastic.
It's just kind of one of these things you keep running away from, and then it's time to tackle it. So.
No, exactly. It is. It's a procrastination thing. I've always been sort of a fan of the benefits that observability are going to bring, but I'm guilting myself of not actually building it into the code I write. And there's a lot of pressures on different budgets. You've got managers. You've got everybody's got those pressures, but. It's nice to listen to Charity because it's an inspiration that we should be doing it more than we are.